Hey everyone, so today we're going to learn how to create a buoyant platform that would react like a real floating object would without all of the use of physics or the Unreal Physics engine, because that can get quite expensive and quite unpredictable quite quickly. So a good example of what we're going to be creating today would be the floating rafts in the Rock Village area of Jak and Daxter, if you're old enough to remember that game. And if you're not, I would highly recommend checking it out because that's one of the better platformers I've ever played. And additionally, this is going to be featured in my company's upcoming platformer called Cones, which will hopefully be released later this year. So this platform is going to do four main things. It's going to rotate slightly as if waves are pushing it up and down. When the player is standing on it, the platform is going to roll in the direction of the player as if being weighed down. It's going to bob up and down if the player jumps on it. And finally, we're going to add in a nice little feature that will allow it to sink into the water if the level designer wants it to. So with that being said, let's get started. So I'm going to be doing this in Unreal Engine 5, but I originally created it in Unreal Engine 4.27, so it should work at least as far back as that, and probably even in earlier engines, because it doesn't use anything that's new or spectacular. So here I've already created a folder called Interactables. In my game, we have it organized into some subfolders, but you don't need this obviously for your project. We're going to right-click, create a new blueprint class, call it use the actor for the basis. We're going to call this BP Floating Platform. So a little note about the prefix I just used, the BP underscore. That's a naming convention Unreal uses. I find it really helpful to keep myself organized, but again, not necessary for this project. So let's open this up. First things first, we're going to need another scene component in addition to our scene root. So I'm just going to search for scene. And what the scene component is going to do is allow us to rotate on multiple axes at once. So for example, a piece of wood in the water is being pushed back and forth by waves or disturbances in the water. And so that's one layer of rotation. But if you have something weighing it down, like the player, then that side is going to need to rotate down to adjust for the player's location. So that's another layer of rotation. And so to have these both going at the same time, because rotators in Unreal can get pretty confusing, and I'm confused by them quite frequently. But to have all that going at the same time, I found it's just easier to have an additional scene component. So within that scene component, I'm going to add a static mesh, and this will be the thing that you're actually standing on. And then finally, we're going to add a box collision. And before we get into the blueprint, hopefully you have a static mesh for your project. For this, I'm just going to use a cube. I'll set the scale of the cube to be 2.1. Then we'll drag this up, bring this out to 4, and set its height to 2. So you want to set the box collision to be wherever the player is able to step on the platform. So that can get a little tricky with uneven objects, but if your object is too complicated, you can always just block it out with multiple box collisions, because the collision itself is not terribly important. We just need to have something to let the system know where the player is. Okay, so in our event graph, we're going to start out by right-clicking. Gonna get the default scene root, and actually we didn't need to do that. You could just drag it out from up here as well. From that node, we're going to get world location. And then we're going to promote this to a variable, call this actor location cache. Next, we're going to drag out the static mesh. We're going to get its relative rotation. And do the same thing for this. Promote it to a variable and call it the relative rotation cache. From here, we're going to drag out a new timeline. And this is just going to be that motion that occurs with waves, so we're going to call it buoyancy. Whoops. And in the update component or section, we're going to drag that out to set relative rotation. And we want to be targeting the static mesh with this. So now we're going to double click on buoyancy. We're going to add a float track, and we'll just call this alpha because that's what we're going to be affecting. And then make sure you check loop right here because this is going to be constantly playing for as long as the actor is alive. So you can change the length of this timeline to whatever suits your needs, but in my game, 3 seconds I thought was pretty good. I'm going to add a key, set both its time and its value to 0. Or sorry, the value is going to be 0.5. At 3 seconds, going to add another key. Its value should also be 0.5. And then at 150, we're going to add another key, and it's going to be negative 0.5. Click and drag and select all 3 of these, right click and set the interpolation to auto. And this will give us the nice calm rolling water movement. So we can close that out. From alpha, going to multiply this times 1 over 15. And the reason we're multiplying it is because if you have too much division, that can kind of become expensive. I don't know that it'll really be too big an issue here, but just in case, I like to do things efficiently. Going to drag out our static mesh again, get its current relative rotation, and we're going to break this into axes, or excuse me, we're just going to break the rotator, not into axes. Then we're going to get some addition nodes. Going to connect both of those to our multiplier. And then we're going to make a rotator and then connect the Z to that. Then we're just going to plug in the rotator into the new rotation. Compile that, and let's see if this is working. So here's our platform. Try it out. And as you can see, it's just slowly moving back and forth between, pretty much just between two angles. Now you can make the motion more complicated than this, but I find for platformers, this is pretty much all you need, because the camera is so far away generally that nobody will really notice that it's just kind of tipping from that corner to that corner. But you can play around with it and, you know, do more advanced things with the timeline and get as detailed as you would like with it. So up next, let's deal with our tick event. So the tick event is going to basically check to see if the player is on the platform by seeing if he's colliding with the box collider. And then if that is the case, it's going to add rotation to the mesh so that it looks like he's being weighed down. We're also going to put the sinking function on here. The reason we're doing that is we could put the sync function on event hit or on damage, but I like it on here because that way the player can just walk onto the platform. He doesn't have to jump and then land on it. So it's a little more complicated doing this way, but I think it produces a better end result. So without further ado, first things first, we're going to drag out the box component. We're going to see is overlapping actor. Then for other, we're going to get player pawn and connect that there. You want to make sure that you drag this out from box when you're getting is overlapping actor, because if you were to drag it out from the player pawn is overlapping actor, you can see the target here is actor as opposed to primitive component, and that can get confusing if you accidentally drag the wrong one out, and you want the one that is target is primitive component. So from here, we're going to branch. If it's true, well, first let's add a new variable, which I'm going to call weight applied. So if the box is overlapping our pawn, I'm going to check weight applied, and if it is not, then we're not going to apply any weight. Set relative rotation of the static mesh again. And we can just connect this right here. Okay, so this is going to get a little complicated. Let's keep this organized. Let's create a new function. We'll call this pivot. Over here, I think this can be pure. Yeah, so let's make it a pure function. Okay, so we're gonna pull out a return node for our outputs. All we need is a rotator. First, we're going to get the player pawn. Going to get his current location with get actor location. And we're going to get the static mesh and going to get its world transform, because we want both the rotation and the location. Then we can split that struct pin so we get both of those. From here, we want to get the center of our buoyant object and compare it to where the player is if he's touching it. So to do that, we're going to get unit vector. We're going to get unit direction for a vector. I'm going to take the actor location, I'm going to convert it to a vector 2D. And the reason we're doing that is just to strip it of its Z value. We're going to do the same thing with this. And then we can just drag this back in here, and that will convert it back into a 3D vector. So then, pull this up. We're going to get the distance 2D, comparing our static mesh's center to the player pawn location. Let's pull this out, normalize to range. And what this is going to do, after we set to the max of being 100, is it's basically going to convert the distance from the center into a fraction, and that'll make it a little easier to work with. From there, I'm going to multiply. Let's promote this to a variable and call it max rotation. And then pull this out. Let's break this vector. Going to multiply x by the inverse of our distance 2D. And then we're going to take y, and we're going to multiply that by our distance 2D. Whoops. There we go. Pull this out. Excuse me. Pull the y out to make a new vector. And then connect this here. And once again, we do not need our z-axis. Going to unrotate this vector. I don't remember what this does. It took me quite a while to figure out this was the node I needed, and this is what I mean when I say rotators can become quite confusing quite fast. But you connect that back to the world transform of your static mesh, or the rotation of your static mesh. Then we're going to split this one more time and then make a rotator. So then we can just drag this out and then take our return value and connect it to our return node. Compile, go back to our event graph. So let's pull out our pivot. Then we need to do a little bit more. Well, we could probably do it inside the pivot function. Yeah, let's do it inside the pivot function. So unconnect that, pull this out, and select rotator. Then we're going to get the relative rotation cache, connect that to B, and then going to get weight applied and connect that to pick A. Drag this out, R interp 2, and we don't want that connected to current, so control click and just drag that down to target. Get static mesh, get its relative rotation, connect that to current, get world delta seconds, and for this we can just set the speed to let's say 5. Try that out. Now we can take this return value and connect it to our return node. So let's try this out and see if that worked. And it did not work. So let's see what went wrong. Well, it would certainly help if we connected our function to the set relative rotation. Let's try this one more time. So now as you can see, we've got the buoyant movement here from earlier, but not much happening in terms of the player stepping on it. Maybe this shouldn't be a pure function. Let's try making it unpure by unticking that box. Okay, so I figured out what went wrong. Was our max rotation variable, which I had not set. It was just set to 0, so I'm just going to try it with 10 degrees and see what happens. And there is quite a bit of movement here because this is a pretty large platform, but seems to be working pretty well. Let's dial back the intensity of that a bit. Let's try 5. Still pretty intense. Maybe 3, and let's make that public so that we don't have to come back into the blueprint in order to edit it. Yeah, that feels pretty good. Cool. So next up, let's do the bouncing movement that would occur if I were to jump and forcefully land on this platform. I'm going to go to event hit. Let's see if this does the trick. We're going to pull this out. I'm going to create a new timeline. Add timeline. Call this bounce. We want this to be connected to play from start, not play. Let's get another set relative rotation. And I think we want this on scene. No, we want this on default scene root. Let's double click here first of all. add a new float track, call that alpha, set the length to 2. And then we're going to add several keys here. First one here at 0. At 0.25. Gonna make that -1. 0.5. Let's make that 0.5. 0.75. Let's do -0.225. At 1 second, we're going to do 0.125. At 1.25, we're going to do -0.0625. And at 150, we're going to do 0. Again, we're going to click and drag, grab all these, set to auto. Let's kind of drag this down so we get a nice smooth curve here. Yeah, and I think the rest of these are okay, actually. Yeah. Okay, so back in our event graph, from alpha, going to multiply that times 20, and we are going to add that to our actor location cache. We can split this, and all we need for this is Z. Add that together. Make vector. Oh, I'm sorry, this should not be a set relative rotation, this should be a set relative location. So let's delete that. Pull that out to update. And this should be in Z. So control click and drag that down there. And then from our default scene root, we're going to get its relative location. Split that and connect X and Y. I believe that's good. Let's find out. As you can see, something horribly wrong happened there, and I don't even know where that platform went. So let's see what happened. Okay, so I think what we need, I think what's happening is that we're hitting it and it's playing this a million times because we keep on hitting it. So we need this to do this only one time. So let's get some flow nodes, do once. And let's just test this to see if this even fixes our problem. It did not. Well, that would certainly help. Once again, always check your connections, because that causes probably 90% of the bugs I have when dealing with this. Let's compile that and see if that works. It does. So we got a nice bouncy movement, but as you can see, because we have the do once in there, it only worked once. So let's disconnect this, but we're probably going to need that a little later on, but let's just see how this works. Got that nice bouncy movement. Looks pretty good. Yeah, we might actually not need that at all. Cool. Okay, and last but not least, we're going to add the syncing functionality. So for that, we're going to create a custom event. I'm going to call this sync platform. Or let's just call it sync. In the tick event, before we apply pivot, we're going to add a branch, and we're going to promote the condition to a variable. I'm going to call that sync. Whoops. Yeah, well, I just named my event sync, so we can't. Let's call it sync platform. Okay, so let's change the condition's name to sync. And then click this I because we want to expose the variable for our level designers. So if this is false, we're going to connect this just straight back to where we were going. And if it's true, we're going to divert to our sync platform function, and then we're just going to come right back to pivot. So for the actual function that it's going to be diverting to, first thing we're going to do is set it to not sync anymore. That's going to kind of work like a do once node because tick runs every tick, or about 1/100th of a second, I believe. We only want this to run once. So by setting it to false, it will do it once and then just divert back, but it'll still work fine. So with after that, let's do a delay. And this is going to be the amount of time that it's safe to stand on the platform before it starts syncing. Can promote that to a variable, call it sync delay. Let's make that public as well. Next, we're going to get our scene component, not the scene root, the scene. Going to get world location. And then we're going to promote that to a new variable, and we're going to call that scene location cache. We can put that right up underneath actor location cache. Gonna add a new timeline. Call this one sync platform. Control click and drag us down to play from start. Double click that. Add a new float track. This one's going to be pretty simple. It's just 0, 0 and 1, 1. And then set our length to 1. Okay, so back here on update, we're going to set world location of our scene component. oops, let's name this track alpha again. Then from alpha, well, let's right click, get an ease function. From there, we can connect the alpha to the alpha and connect our result to new location. Then we're going to get our scene location cache, connect that to A. Then we're going to add -100, connect that to B. After that, I'm going to drag out finished, set scene location cache, and we're just going to duplicate that, the scene's world location, and connect that here. From there, we can duplicate all of this, pull it down. Let's rename this timeline Raise Platform. Gonna get the scene location cache. Gonna do another delay. This will be the amount of time that it stays underwater. So you can set that to whatever you want. I'm just going to set it as 2. Now we're going to drag this into play from start again. And then let's change this from -100 to 100. And then once that is finished, we're going to re-enable sync. Okay, so let's try this out. Nice. Well, it didn't look like that set correctly. Is that correct? Get rid of these physics objects, they might be interfering. Okay, cool. So that works. We didn't set our initial delay to anything, or it's just its default value, so let's set it to 1. And now let's make the motion feel a little bit better. I think ease in out probably works best for this on both of them. And actually on Ray's platform, let's set its length to 2 and then change our second value here to 2 seconds. And that way it feels like it's struggling against the weight of the water as it comes back up, whereas when it's being pushed down it feels like the water is really forcing it down. Awesome. So yeah, in an actual platformer, you probably wouldn't continue standing on it as it sank, because it would probably kill you. At least that's what typically happens. But yeah, so if you're jumping from platform to platform, jump off. Platform goes down, and then if you need to go back over it, it'll come back up after the delay. And yeah, and if we uncheck sync, come back over, and we've got those nice multiple layers of rotation of the wave buoyancy and then the pushing down from the weight of your character. Um, in my game, I've applied this to several different objects, and it's worked pretty well on all of them. I have like a pallet object and a barrel object that I got from the Unreal store. And you do need to adjust that box collision to make sure that it makes sense, so that it always knows where the player is when they're stepping on it. But yeah, it looks great, and I believe you can rotate this in any direction, and it should still function correctly. And you can set the actor location and have it move along a spline if you want to have like a moving platform. And because these aren't using like they aren't setting the world rotation, they'll always feel correct as the player runs across them. So yeah, that pretty much covers my first tutorial here on Unreal. I hope to be doing many more in the future. Let me know what you think of this. I appreciate any comments or criticism you have of this, and let me know if you'd like to see anything next or what you'd like to see next in the future. Just want to do a quick shout out to a few people who have really helped me on my Unreal journey, and I think they can help you a lot on yours too. One is Ryan Laley. He's a British Unreal instructor who's working on the game Mimic right now, which should be released pretty quick. He's amazing. I definitely recommend his videos and live streams. You can also pay him to do one-on-one tutoring with you, or you can just pay him to work on your game as well. He's a jack of all trades in that way. Second, Matthew Wadstein. I haven't seen him post in a while, but he has a great series called WTF is this node, and he basically goes through every node in Unreal and explains what it does and has examples of its applications. But he hasn't been around for a while, so his stuff is basically limited to Unreal 4, but most of that works with Unreal Engine 5. And then finally, Clockwork Ocean and Mindbrain on the Unreal Engine forums. Both have been great resources and have taught me a lot. So with that being said, I'll see you guys next time.